Hello students, in today's lecture we are going to learn about systems of particles and rotational motion, NCERT section 6.4 to 6.5 and example 6.4. This is disclaimer. Learning objective. By the end of this lecture you will able to understand the concepts of linear momentum of center of mass, Newton's second law for a system of particles, conservation of linear momentum for a system of particles, and vector product of two vectors. So in today's lecture we will cover first 6.4 linear momentum of a system of particles, then vector product of two vectors, then example 6.4. So these are the topics of the today's lecture. We will learn each one by one. The first, linear momentum of a system of particles. So here in this section we will learn about a linear momentum of a system of particles. It means we have a system and then we will find their linear momentum. So basically linear momentum defined as the product of mass m of an object and its velocity. It means suppose if we have any object and the mass into velocity of that object gives the product of mass and velocity gives their linear momentum. Mathematically, linear momentum of a particle is given as P is equal to mass into velocity. So this is the mathematical relation of the linear momentum where m is the mass and v is the velocity of the particle. Linear momentum is a vector quantity. It has both magnitude and direction. So from Newton's second law of motion, we can say rate of change of linear momentum is given as F is equal to dp upon dt. So this is from Newton's second law of motion, rate of change of momentum, where we know F is the force of single particle of a linear momentum P. F is the force on a single particle. So using this relation we will find out the force on a system of particles, then we will find out their linear momentum. So linear momentum of center of mass, we know center of mass means a point where whole mass of the body to be concentrated. So consider a system of n particles with masses m1, m2, mn and velocity v1, v2, vn respectively. So we have a system. So if we talk about particle first, so their mass is m1, velocity v1. If we talk about particle m2, second particle, so their mass m2 and velocity v2. Similarly, if we have a particle nth particle, so their mass is mn and their velocity is vn in the system. So linear momentum of the whole system P is given as a vector sum of momenta of individual particles. It means in this system we have a more than 2 particles, or we can say n particles. So their linear momentum we can add as a vector sum. Like if we talk about the particle first, so their linear momentum is P1. If we talk about the particle second, their linear momentum is P2. Similarly, if we talk about the nth particle, so their linear momentum is Pn. So this is a vector sum of all individual particles. Vector sum of linear momentum of all individual particles, and P is the total linear momentum, or we can say linear momentum of system. So we know P1 is the linear momentum of particle first. So in the form of their formula, it will be m1 v1 plus m2 v2 plus mn v1, and which is equal to P. We know P1, P2 and Pn are the momentum of individual particles. So for a system, we can write the total linear momentum of a system, P is equal to sum of vector sum of momenta of all individual particles. Clear? Linear momentum of center of mass. Now we know velocity of center of mass V of a system of nth particle in terms of its individual particles is mv. Capital M is the mass, center of mass. V is the velocity, center of mass, and m1 v1, m2 v2. Similarly, mn vn is the linear momentums of individual particles. So therefore total linear momentum of the system is P is equal to mass into velocity. So this is the total linear momentum for a system, not for an individual particle. For individual particle, this one. For particle first, their linear momentum is m1 v1. For particle second, their linear momentum is m2 v2. And for the total system, is the linear momentum is the sum of vector sum of all vector sum of linear momentum of individual particles. So that is mass into velocity, capital M into capital V, where V is the velocity of center of mass. Thus, our total momentum of a system of particles is equal to the product of total mass, that is M, of the system, and the velocity of its center of mass, that is V. So remember this is very important concept. P is equal to mass into velocity. So Newton's second law for a system of particles. So we know Newton's second law for a system of particles states that the net external force acting on a system is equal to rate of change of total linear momentum of a system. So mathematically, we know the linear momentum of a system is mass into velocity, capital M into capital V. So to get the force, we can differentiate here. Differentiate P with respect to time. So P is equal to mass into velocity. So taking the differentiation, dP upon dt is equal to M is the constant, so it remains same, into the differentiation of V with respect to time, it will be dV upon dt. Now M is the system, M is the mass of the total system, that is constant here. So this is the linear momentum of a system, a rate of change of linear momentum of a system in terms of velocity. So therefore rate of change of total linear momentum is given as dP upon dt is equal to mass into acceleration, where A is the dV upon dt is the acceleration of center of mass. So now using the Newton's second law of motion, we will find out the force here. So the external force F external on center of mass is ma, mass into acceleration, is equal to F external. So we know dP upon dt is equal to F external, rate of change of momentum. Now this is Newton's second law for a system of particles, that is net external force acting on the system is equal to the rate of change of total linear momentum of a system of particles. The important point here is this is the rate of change of momentum for a system of particles, for a system, not for a individual particle. Clear? So conservation of linear momentum for a system of particles. So let's see first statement. When the total external force acting on a system of particles is 0, the total linear momentum of a system is conserved, or we can say remain conserved. It means we can say according to linear momentum, the net external force on a system of particles is 0. So total linear momentum remains constant. So let's see, when sum of external forces acting on a particle is 0, it means F external is equal to 0. So by the Newton's second law of motion, we can say rate of change of momentum is also 0, because external force acting on a system of particles is 0. So dp upon dt is 0, so we can say the linear momentum of a system of particles is constant. Now here, this capital P is a linear momentum of a system of particles. So this is a constant and a vector equation. So in component form, the total linear momentum of a system, we can write P is equal to Px I cap plus Py j cap plus Pz k cap. Here I cap, j cap, k cap shows the unit vectors. So Px, Py, Pz are the components of linear momentum and x, y, z axis respectively. Therefore, we can write here when external force acting on a system of particles is 0, it means here Px is equal to C1 and Py equal to C2 and Pz is equal to C3 we considering. So C1, C2 and C3 are constants. So when total external force on a system of particle is 0, the total linear momentum of center of mass P is a constant. So we can say linear momentum of system P is equal to mass into velocity. We know this. Therefore, velocity of center of mass V also remains constant when external force is 0. It means if the net external force on a system of particles is 0, so the linear momentum remains constant. If the linear momentum P remains constant, so we can say velocity of center of mass V also remains constant. Got it? So due to internal forces, particles may have complicated trajectories, but if external force acting on a system of particles is 0, center of mass moves with constant velocity along a straight line. It means here we talk about the external force. So in that case, if the external force is 0, so there is no change in the movement, or we can say trajectory of path of system of particles. So center of mass moves with a constant velocity because the external force is 0. But if we talk about the internal forces, so due to internal forces there is some complication, but it does not affect on the path of the trajectory. Let's talk about an example to understand it better. A radioactive decay of nucleus of radium into nucleus of radon and an alpha particle. So a heavy nucleus, a radium, splits into a lighter nucleus. First radon and second is an alpha particle. So the center of mass of the system is in a uniform motion in case first. In second case, the same splitting of the heavy nucleus radium with the center of mass at the rest. The product of two particles fly back to back. Let's see. So a radium nucleus disintegrates into a nucleus of radon and an alpha particles. So we have a radium nucleus Ra. This is the element symbol Ra, radium nucleus. So this radium nucleus disintegrates into two or more parts. So here first part is helium nucleus, second is the radon. So forces leading to decay are internal to the system and external forces on the system are negligible. It means, so the responsible force to disintegration here is internal force. So we can say the external force is 0. So the total linear momentum of the system of particles remains same before and after decay. Yes or no? Because the external force is 0. The responsible force for decay is only internal forces here. So we can say the total linear momentum of system of particles remains same before and after. So P is equal to constant. I hope this is clear. So particles produced in the decay, radon and alpha particle. So after disintegration, they will move in different directions. First, it will be, we can say, towards the like maybe approx 45 degree from the horizontal, and similarly radon, or in simple words we can say this is move in different direction. It does not we can say uh, specify here, in different, randomly after disintegration it moves indifferently. So but center of mass of radon nucleus and alpha particle move along the path along which the original decaying radium nucleus was moving. It means the center of mass move along the original path. From the frame of reference in which center of mass is at rest, the product of particles move back to back with their center of mass remaining at rest. Now we will learn vector product of two vectors, and this is very important concept. So let's see first definition. So vector product of two vectors, a vector and b vector, is a third vector C such that C vector is equal to a vector in cross v vector. It means what? It means suppose we have a two vector, a vector and b vector. So their cross product, a vector cross b product, gives a third vector C here. So this is the definition of vector product. So if we have two vector, let's see, a vector and b vector, and their cross product, or we can say vector product, and the angle between a vector and b vector is 0, or we can say here theta. Angle between a vector and b vector is theta. So the third vector is perpendicular on this, like this, C vector. So if we talk about the magnitude, when we take the vector product of two vectors, a vector and b vector, their magnitude CS, magnitude of C vector is equal to magnitude of A cross B. So it will be what? It will be magnitude of C vector is equal to AB sin theta. So theta is the angle between A vector and B vector, and A and B is the magnitude of vectors A vector and B vector. If we talk about the direction of the vector C, so here to find out the direction of vector C, we will use the right hand thumb rule. So we have a vector, this one, B vector is this one. So to find out the right hand thumb rule, so from A vector to V, move your four fingers from A vector to B, A to V, and their thumb, your thumb gives the direction of the third vector. So right hand thumb rule states that if you curl the fingers of your right hand from A to B, suppose A vector is this one and B vector is this one. So when you curl your fingers from A to B, listen carefully, from A to B, your thumb, this one, your thumb gives the direction of the third vector. So this is the C vector, that is, or we can say third vector. So this is the direction of A cross B. Clear? And this is very important concept. Properties of vector product. So first property is non-commutative property. So vector product is non-commutative. It means that the order of vectors in a cross product matter. Order of vectors matters here if we talk about the cross product. So it means A cross B is not equal to B cross A. This is the first property. Magnitude of A cross B and B cross A is same, but the direction is opposite. Listen carefully. If we talk about the vector product or cross product, A cross B not equal to B cross A, but their magnitude of A cross B and magnitude of B cross A is same. but the directions are different, or we can say in opposite direction. So we have a two vectors, a vector and b vector. If we take a cross b, a cross b, so according to right hand thumb rule, so the direction of product of a cross b gives the uh, thumb, so that is upward. So this is the a cross b. But if we talk about the b cross a, b cross a, so direction will be downward, your thumb directed towards the down. So this is important concept. So like see, we have a two vectors, a vector in this direction or b vector is in this direction. So if we take the cross product, so curl your fingers like this towards the b vector. So your curl, the thumb gives the direction of third vector. Similarly, if we b cross a, so this one is the this direction is b vector and this direction is a vector. So curl your hand like b to a, b to a. So it gives the direction of third vector, that is minus a cross b. So here minus sign shows the opposite direction. Clear? So we can say a cross b is equal to minus of b cross a, because the directions are opposite. I hope this is clear, because this is a very important concept. So second property is distributive law. So vector product obeys the distributive law. This means that any three vectors, a vector, b vector and c vector, we can write a cross b plus c is equal to a cross b plus a cross c. So first we take the cross product of with b, then plus sign, after that we take the cross product with c vector. So this is the distributive law. Under reflection, that is on taking the plane mirror, a vector is equal to minus a vector and b vector is equal to minus b vector. So we can say a cross b is equal to minus a vector into minus b vector. So it gives minus minus cancel out. So a cross b is equal to a cross b. A cross b does not change under reflection. Clear? For a two parallel vectors, parallel means suppose first vector in this direction and their head and tail. Suppose first vector and first is this one and second is this one. So both are parallel. So if we talk about the parallel vectors, the direction is the theta is 0 degree. If we talk about the anti-parallel, suppose the vector is moved like this. So first in forward, second one is the backward. So in that case, the angle between the vectors is 180 degree. So here we can say for parallel vectors, angle should be 0 degree. For anti-parallel vectors, angle should be 180 degree. Got it? So a cross b, we know AB sine theta. So a cross b is equal to AB for parallel vectors. Theta is 0 degree, so sine 0 degree. So it gives a cross b equal to 0 for parallel vectors. Now if we talk about the anti-parallel vectors, so in case of anti-parallel vectors, theta is 180 degree. So a cross b is equal to what? Sine 180 is 0. She also gives a cross b equal to 0. So the cross product of a vector with itself is 0. So a cross a is equal to magnitude of a into magnitude of a sine 0 degree. Now here this is important. Why the cross product of a vector with itself is 0? Because the here angle is 0 degree. Angle is 0 degree. So just put the value of theta in the formula, you will be get the a cross a is equal to 0. So a cross a equal to 0. So a null vector, a vector whose magnitude is 0 and direction is arbitrary. Now orthogonal or orthogonal unit vectors, I cap, j cap, k cap of a right-handed coordinate system. So this is the right-handed, I cap, j cap and k cap. Now this is important because it shows the directions of vectors. So I cross j gives k vector, k cross I gives k cross I gives j vector and j cross k gives I vector. So this is anti-clockwise. I cross j k vector, k cross I j vector, and I cross j k vector. So this is a important. If we talk about j cross I, so j cross I gives minus k cap, and k cross j gives minus I cap, and I cross k gives minus j cap. Clear? And I cross I equal to j cross j equal to k cross k equal to 0. So this is the important property of vector. So consider two vectors. We have a vector is ax I cap plus ay j cap plus az k cap. B vector is bx I cap plus by j cap plus bz k cap. Now take the cross product. So it will be a cross b. So ax I cap plus ay j cap plus az k cap cross bx I cap plus by j cap plus bz k cap. To solving this cross product, we will firstly use the direct method, that is ax I cap into bx I cap. So like this, ax bx I cap cross I cap. Ax bx and ay by and az bz is the only constant terms. Only the important term here is I cap, j cap and k cap. So I cross I, similarly if we multiplied ax I cap with by j cap, so it gives ax bx I cross j and ax bz I cross k. So if we multiply ax I cap into bz k cap, so it gives this one. Similarly for now we will start ay j cap with bx I cap, then by j cap, then bz k cap, so it gives this one. And for last one az k cap multiplied with bx I cap, then by j cap, then bz k cap, so it gives this one. So this is the cross product, and this is very little bit complicated. The simple method is determinant form. So or we can say matrix form. So by using the matrix form, we will find the cross product of two vectors. So this one ay bz minus az by I cap plus az bx minus ax bz j cap plus ax by minus ay bx k cap. So this is from using by using the matrix form. So in determinant form, a cross b can be written as like this. So this is very easy method. So to take the two product, cross product of two vector, so we have a two ax I cap, ay j cap, az k cap, bx I cap, by j cap and bz k cap. So first if we talk about I cap, so neglect I cap column and the remaining column is this one, I cap, j cap and k cap. So take the cross vector product, ay bz minus a b by az plus then for j cap. So neglect the j cap column, the remaining column is I cap and j cap. So ax bz here, ax bz, or we can say bx az minus ax bz plus now k cap. So neglect the k cap column, remaining columns is ax by minus bx ay. So this is the simple calculation method as compared to direct method. So this is the cross product of two vectors. Example 6.4. Find the scalar and vector products of two vectors. So here you have two vectors and you have to find out the scalar product and vector product, or we can say dot product and cross product. So please find. You have some time. Let's see the solution. Now taking the scalar product a dot b, so it gives ax bx plus ay by plus az bz. So a dot b, ax is a vector is 3 I cap minus 4 j cap minus 5 k cap dot B vector is minus 2 I cap plus j cap minus 3 cap. So I cap, it means I cap or I cap 1. So 3 into minus 2, it gives minus 6. For minus 4 into 1, it gives minus 4, and 5 into minus 3, it gives minus 15. So solving this, you will be get minus 25. So this is the scalar product of two vectors. Now vector product. So we have a two vector, a vector and b vector. So their cross product is we will solve using the matrix form. So I cap, j cap, k cap, ax, ay, az, bx, by, bz. So put the value of ax, ay, az, bx, by, bz. You will be get like this: ax 3, by ay minus 4, and az 5. Similarly, for the second vector, that is b vector, here for ax minus 2, for ay 1, and for az minus 3. For az, this one 3. So solving this, you will be get a cross b is equal to 12 minus 5. So 12 minus 5 I cap minus say it's for minus 9 plus 10 j cap plus 3 minus 8. 3 minus 8 k cap. So this gives the cross product. So solving this, you will be get 7 I cap minus j cap minus 5 k cap. So we know b cross a is equal to minus a cross b. So we can write b cross a is equal to minus I cap plus j cap plus 5 k cap. Clear? Summary. Linear momentum is the product of mass and velocity of particle. P is equal to mass into velocity. Total linear momentum of a system of particles is P is equal to mass into velocity, where m is the total mass, v is the velocity of center of mass. Newton's second law for a system of particles, dp upon dt is equal to F external. Summary. F external is 0 on a system of particles, its linear momentum is conserved. So P is equal to constant. When P is equal to constant, center of mass moves with constant velocity along a straight line, even though individual particles may follow complicated paths due to internal forces. Magnitude of vector product of two vectors a cross b is c. Mathematically, c is equal to ab sin theta. Now here we have some practice questions, that is homework for you. If no external force acts on a system of particles, what happens to the velocity of its center of mass? When external force is 0, what can you say about the path of the center of mass of a system? Third one, two particles of masses 2 kg and 3 kg move with velocity 4 meter per second east and 2 meter per second west respectively. Calculate the total linear momentum of the system. A system of 3 particles has total mass 12 kg and moves with center of mass velocity of 5 meter per second. Find the total linear momentum of the system. Fifth one, an object of mass 5 kg splits into two parts of mass 2 kg and 3 kg. If the 2 kg mass moves at 6 meter per second in north direction, but what must be the velocity of the 3 kg mass of the momentum conservation? So here you have to find out the velocity of the second particle. Clear? So these are the practice questions for this is homework for you. Clear? Thank you for your attention.